So we went over all this part already. You guys should have heads up on that one. And now we did all of that. So now we were on, I had put 2 chapters 8s in there. I don't know if you noticed. I don't do both chapter 8s, just one in chapter 9. Okay. All right, so now chapter 9. Let's do that, the final review of chapter 9. Now, when we talk about chapter 9, we're talking about, yeah.
What time is our final?
I think it's same time, isn't it? Same time. I can have one if you want. You know, I mean, I'll be here. So if you want, I can review again. What time is the final? Same as this class. Yeah, I think it is, yeah. But it's on Wednesday, right? It's on Wednesday, so we have Monday. Normally, I think it's final week, but I don't care if you want. I'll be here, so just if you want help. Yeah, I wouldn't know why you'd want help now, the very last day. Just kidding. But anyhow, here we have it. Okay, so what I'm saying about chapter 9 is that we're talking about 2 samples. Remember, hypothesis testing has always been about 1, right? Now we have 2. Okay, when you have 2 samples, you have to worry about certain things. When you look about the distribution, you also want to talk about the variance. If the variances are very close to each other or equal, we're going to use this thing called pooled variance. All right, so that's what you have to do, is know if you know what sigma is, or if you know you suspect that they're close together, then you're going to do pooled variance. All right, and the other thing we need to know is whether the 2 samples are independent or dependent. That's pretty much it, except for the very last thing, or the penultimate thing, is that you're going to have to. Well, we're going to use. Well, with regards to 2 samples, we can also, if they're paired, like before and after, then you can take the differences and be back to a single sample. You understand what I'm saying? Okay. So let's see how you might address this one. So this guy manufacturer, well, the thing how fast this paint dries. So we have, well, A is like the original 73 hours, and this one 65 hours, right? And 4.5 and 5.1. And these are the sample sizes. So we have the deviation. So, and they're telling you what the confidence interval is. Okay, and it's just simply asking, what does it suggest? And here's the possible answers. So look at this thing, right? Just by looking, now this is a confidence interval. It didn't even tell me. Oh, here it is, 98% confidence, right? So what can I say about the difference? Well, one thing I can say is that you notice that these numbers don't cover 0. They're beyond 0. They're starting at 4 and go to 17, right? So if it's not 0, they can't be equal to each other. Do you understand what I'm saying? I'm just reasoning it through. So there must be a difference. Okay, so now, how is the difference set up? So it says, okay, so the confidence interval includes only positive values, which suggests that the 2 populations might be equal. No, right? Do you agree? No. Because the populations, if they were equal, 0 would be inside this range. Does anybody know what I'm talking about? Okay, so let's see what we got here. The confidence interval includes only positive values, which suggests that the mean time for painting A is greater than the mean drying time for B. You like that one? I like that one. Why do I like that one? Anybody? Well, we already know that 0 is not contained in here, so we both agree that it's probably not going to be accepted, yeah? So there's a difference. So this is saying that it does look like this takes longer to dry than this. Okay. Now that's it. That didn't require much. Okay, next problem. Okay, 2. Find the number of, this is pretty easy. This is like Algebra 1 or something. The number of successes, X, suggested by, the computer says that out of 2,680, 1.9 of these were defective. So that's not even, that's like a baby calculation, right? Actually, that's like, if you look at it, that's pretty close to 2%, right? So 2% of 2,000 is like what, 40? And 2% of 80, it's 1.6, 16? 40 and 16? Did you get it? This is stupid. I just have to take 1.9% of how many, and that's how many defective. What the heck? Oh. Okay. Are we okay? You got 53? I did it in my head. So I did it with 2%. Okay. So let's say it's this one. I mean, you got, okay. You're going to make me do it. Let's see. Here we go. Because I estimated it with 2%, remember? So here we go. So now I have 2,680. Yes? And I'm going to have that what? Maybe it's time to change the battery. And I'm going to multiply that times what? I did I? That's because it's not working. Oh. Get out of the way. Okay. Did I? Okay. And I'm going to multiply that by point what? Yes, because if I get rid of percentage, that means you're making see, that's a 100. It's all scrambled up. So if you want to get rid of it, you have to divide this number by 100, which is effectively moving it 2 places to the left. It's got to get smaller when you divide. Point 0. Oh, wait. Point 0 1 9 8. Right? 1 2. Okay. Yeah, 53. So I estimated with 2%. I was a little bit high, right? Because I did it in my head at 2%. So she was right. Okay, I was estimating too freely. I like this. Okay, next one. Determine whether the samples are dependent or independent. The effectiveness of a new headache machine is tested by measuring the amount of time before a headache is cured. For patients who use the medicine, another group of patients use a placebo now. Do you think it's dependent or independent? Why do you say independent?
That they're using the same group, they're using a placebo?
Yeah, but if you're using the same group, what problem is number 3? So independent? 3A, right? Okay. This is the second part of the review of the final. This is chapter 9. Determine whether the samples are dependent or independent. The effectiveness. Oh, what did I do? Does that twice?
No. It's not the same. It asked it a different way.
Oh. Determine whether the samples are okay. The effectiveness of testing the intensity of the headache in patients before and after. Okay. Before and after necessarily dependent, right? Oh, this is an easy test, isn't it? I'm glad. Okay, so let's go on. Okay, now, this is what you were asking about. I think some of you were wondering, how can I use StatCrunch to answer some of these questions? And so it's a matter of learning it. So here on StatCrunch, we want to construct a confidence interval with a 90%. But notice what do you see what this UD is? This mu D? Do you know what mu D is? Okay, you got to have a before and after, yeah? And you take the difference between the two, and you have a column of differences. That becomes one information that we can use like to run our confidence interval. But let's try the stats here. And can somebody write down this? Because I got to put it in StatCrunch. Does anyone got this? Oh, you got it on your, you got your test, right? Okay. So let me see if I got it here. All right. So let me go here. Okay. So let's see. Okay, now I can do this. Okay. I'm gonna, oh, can I go here? Okay. What's the first number?
For the first number for A is 5.0.
5.0.
5.1.
Wait a minute. Why does it do that?
I don't know, like, I think it's just.
Oh, it's 5.0?
Yeah, it's
Oh, why
5.0,
would you
so
tell me that?
it
Yeah.
doesn't matter.
Oh my gosh, yeah.
It's 5.1 after that. 4.6. 3.5. And 6.
Okay, and this one?
That.
And then 3.7? Okay. All right, okay, so let's get through that, and let's get rid of this. Okay, now, here, so if we go to stats, okay, now, what are we looking for? This is a difference. We were looking at the difference of two samples that are dependent, correct? So we go to stats, let's see. And now I'm looking at mu, right? We're looking for mu. So let's say if I don't know if it said it was normally distributed, but let's say I go here, we'll try it. And I have, well, yeah, I have two samples, yes? And then we have data, right? Okay, so we got here, let's see if this works. So it's, I have variance 1, and column 1, column 2. And then we want to construct a confidence interval, yes, of 0.99, is it? 90. Okay. Let's see if this is going to be the difference. Let's see if I got it. Okay. Hi. How you doing? Oh, yeah. Cool.
See ya, Lloyd.
Yeah, bye. So, where am I at now? Number, what problem are we on? That's the one, oh, that's the next page. Yeah. Okay. Do we have that? I don't quite, I don't have a negative 0.22, do I? Okay. And I don't even have an upper bound of 1.4. So let's say, let me see, construct of the difference. Okay, let's try of the difference. Let's see what happens here. Yeah, okay. Let's go and try this. Stats. Let's try the T. Let's try the 2 sample. Oh, is it paired? It's paired, isn't it?
It does say population of pair difference.
Okay. Sample 1, variance 1. Sample 2, variance 2. We're going to have the differences, yeah? And this one is going to be what? Set to what? Yeah. Okay, let's try it now. Okay, we have 0.36. Yeah. Okay, so like B. Here is the confidence interval.
Yeah, 'cause they're rounding.
Yeah, so it looks like it's probably going to be B. Now, if you want to do it by hand, and there is an equation for, if you recall, it's something like, if you recall, now we're talking about, we wanted a confidence interval over, do you remember the difference of the two? Well, actually in this case, we just want, anyway, that's what it is. Okay, we have that, and then we have to put that between what we use, right? That was x bar 1 minus x bar 2, right? Plus an error term. Okay, and then we have over here x bar 1 minus x bar 2, you know. And you want the probability of this whole thing to equal, and that was 90.90. Now, the error term is quite a few calculations. So if you have this, if you have the printout of the formulas, you'll see that there's an equation that shows you the confidence interval. But this did it all right now. So for those of you not going to use StatCrunch, or I don't know, you can do it on a calculator, but you have to use the equation on the notes that shows you, what it is. Any questions? It's too easy? Okay. That was a little bit, let's see. Okay, now, when I go in there and, oh, look. See, it gave me a group of differences. It automatically included there. All right, how about the next one? We're on number 6? Okay, so we got to enter some data. Let me, I don't know if it's, and then, test of abstract reasoning is given to a random sample of students before they are completed a formal course in logic. The results, we want to construct a 95% confidence for a mean difference before and after. So that's the same we did. Let's see. So I went here, but I went to the t-test, and I went to paired. Okay, and then over here, I just had to select. So I got the column variable 1 and the column variable 2. Okay, and then I'm putting here that I'm talking about the two sets of data, but I'm talking about the difference of the two. Okay, and I'm not looking at the hypothesis right now. They asked for a confidence interval of 95. Is it okay? Let's compute. Okay, so 0.69. Shoot, I don't see it. 0.06, I mean, yeah. Is there one? Are my numbers correct? Wait a minute. What happened here? Oh, it's over here. Okay. My differences are over there. Are these numbers, let's see. 74, 83, 75, 88, 84, 63, 93, 84, 91, 77, 75, 84, 95, 67, 74, 70. Okay. What's going on here?
Did we possibly put in the right columns?
Yeah. That's, okay. But it wouldn't have worked, would it? Let's see. Does there a, oh, I did, they went here. Oh, okay. Thanks. So let's go stats. We were talking about this. We're talking about paired. We're talking about, okay, this is going to be DF. And this is going to be whatever. F limits. Differences? Oh. Okay. All right. Is that the same numbers? Oh, there's a 7.48, but that's not it. And it's 0.16. Degrees of freedom is 9. That's right. Let's see. Okay, the test, the reasoning is that the mean difference between before and after. Where did you get that?
I took it accidentally. Forgot to leave it here.
Oh, I got 2 of them now because I took. You want to go to the other room?
Is it one? No,
Oh.
maybe the other one. They're marked. I'm sorry.
I thought I was getting older and I just
You're
misplaced
getting
it.
senile, yes.
Yeah.
That's not yours class schedule, is it?
It may have been at one day, 1 year. What's the date on there? Like 2018?
Well, if that's yours, we can't leave these things out.
Oh, I don't know if it's, no, it probably is. Where'd you find it?
It was on the table out in front.
Oh,
So I just,
I was using it for scratch.
oh, well, you can't use that because of the,
Don't you remember that time I overprinted? The first day of like, I was trying to use that up.
yeah, okay.
Yeah, but thank you. Thanks for that too, yeah.
Didn't mean to take it.
Yeah. What did I do wrong? Oh, okay, so now it's just looking for this. Oh. Okay, look, watch. I got my differences, right? Right? So I can just go here then. Let's see. Stats. And then let's say that. And let's say one sample. And let's say what data. And let's say we want, okay, now this guy, I got to be careful now. Because I'm using, it doesn't let me do it. I feel like retarded, doesn't it? Okay, oh wait. It's just the differences, isn't it? Okay, now, confidence. Yeah, yeah. Notice that I hadn't had to select difference because they are already differences. Okay, so drum roll. That looks better. No, it doesn't.
There's two columns that say differences.
Huh? Oh, there is?
Yeah.
Oh, yeah. Okay, I'm doing almost about as wrong as you can be. Let's see. Okay, so it's the second row of differences. Okay, so let's try it again. Stats, T, one table with data, and it's the second differences. Is that in here?
Well, now there's only one showing up.
Well, is it differences? But I don't know if, yeah, it has to be, right? Because I took it away. And I want a confidence interval, right? Okay. Okay, there. Well, I got 7.2. And this is supposed to be, why is this? What, the answer is B?
Yeah.
Well, I know those numbers are right, so the difference has got to be right too, because, you know, there it is. And that was the differences. I don't know. Stats. Whoa, let's try this. Two sample with data. And then, wait, it's two samples. I don't need two samples. Right? I need stats. I need one sample with data. And its differences. And then I want confidence. Yeah. It's like, that's not right, huh? Well, the other one was closest. Let's see. This one? If I put paired and differences, then they want, is it variable 1 and 2? Or is it this and this? Is that where my data's at? Huh?
I think so.
Let's see. Yeah, DF and L limit. And let's contract that. Let's see. I don't know. This is correct. But I don't know what's lagging with my less guy. I'll let you figure it out. I don't know. It worked either way, so. Degree to freedom is 9. So what's the round off here? How do they want us to round it up? They don't say? Okay, well, it's B. Hopefully, I'll give you credit if it, because I don't know what to do. Unless we do it by hand. But I'd rather not. Has everybody got this then? It's the answer's in the answer key says B, but and it's right on the right side. Actually, you're right. If it goes 1 decimal point, we're okay, huh? Because you would round up 1.6 to 0.2. Okay. Now let's try it again. I mean, not this one, but okay. And get rid of that. Okay. Now. Okay. Next problem. Problem number 7. Yes. Okay, now, in the context of hypothesis test for 2 proportions, what is the following statement about pooled? Do you remember what I told you about pooled? That means that you're thinking that they're, the variances are about the same or very small. So, so it says, which are true? So it estimates the common values of P1 and P2 under assumption of equal proportions. Okay, and then the other one is it's equal to the proportion of successes in both samples combined. That's the p-bar. Do you see the p-bar? We've had p-hat, but not p-bar. P-bar is the pooled variance. So it's saying it's D, right? 1 and 3? Okay, when you look at the second one, it is obtained by averaging the 2 sample proportions, p hat and p1. Obviously not. We never average p hat 1 and p hat 2. Just there's no reason that I know of. Okay, number 8. Assume you have a significance level of 0.05, and you're testing the. Is that a 1 or 2 sample? Number 8. 2 sample because it's P1 equals P2. We're saying there's no difference in the proportion. Do you agree? And then they said, use the sample size and number of successes to find the p-value. Okay, now you see what they give you? They give you N1, N2, and they give you X1 and X2. What's X1 and X2? No, X1 and X2 in this case, number 8, is the number of successes. Right? And your sample size is 100, but your number of successes that you're talking about with regards to the proportion that you're talking about. Is that okay? Okay, so on that one, we're doing a proportion, right? Now here's what you were asking. I think you were asking me one time about how to do this. So we do proportional statistics, right? And we have 2 samples. Okay, now here's where you put with summary, because we don't have data. So here, now what was the number of successes for the first sample?
38.
Okay, and the number of observations?
100.
And the next one?
40.
Okay. And are we doing a 2-tailed test? Or what are we talking? What are we trying to find here? What was the confidence interval? 99? So I have to go here to put 99. Okay, good. Okay, let's try it again. This will keep you on your toes. Okay. I'm trying to bias the statistical study in my favor. Okay. Let's see. All right. What do we have? What are we looking for? Oh, p-value. Okay. So I want a p-value, right? Remember, that's the area to the right of the or left of the test statistic. So I was okay, but I'm going to go here. I'm going here with summary. I'm going to do it again. That was what, 30, what? over 100. So let's do it again. 3, 8. You know, I could have just edited the other one, and this is 100, right? So, and this is, oh, I did it again. Okay, now, I'm gonna just do this to change it, but then I'm gonna go back. And I'm not sure it'll make a difference, but I'm gonna put 9 in there. Oh, I just saw that. Okay, but I'm going to select up here, right? Look at the null. It says there's no difference. That's equal to 0. That's the same as saying P1 equals P2. Okay, let's try that. All right, now we get our famous p-value. Okay, and it's there. It's letter D. Okay. Again, we can do this by equation, by hand, to find the area from the test statistic over. And remember, if it's a two-tail, you're going to double the p-value. Okay, any questions there? Is it too easy? Okay, here's another one. Construct a confidence interval for the difference of D. That's the difference of for a population of paired data. Assume the population paired data is normally distributed. That's one of the conditions. A test writing ability is given a random sample of students before they complete the formal writing test. So this is a before and after, right? Before and after whatever they did to see if their grades improved. Do you agree? Okay, so this one I have to do it again. I know I'm gonna, but this time. Okay, so let's get rid of all that. Okay, does somebody want to read that to me? Aren't we at a data set? Or what are we looking at here? Yeah, it's about means, right? But of the difference. So let's see if we can do that. So let's see. I'm going to go stats. I want to go, these are means, right? So it's going to be not a proportion. So it's either this or this two, right? Because we're talking about mu. We're not talking about P, are we? And we're not talking about sigma, deviation, or variance. So I need something like this. Now, they're paired, aren't they? Before and after?
Yes.
Okay, column 1, variance 1. Column 2, variable 2. I want the differences. Am I looking at a hypothesis test here, or what am I doing? I just want the critical, I want to construct a confidence interval. Yeah. And at what significance level?
99.
Another one at 99. There. Ready? Drum roll. Okay. Okay, looks like A, right? It's easier with StatCrunch, don't you think? I didn't have it in my day. Okay. Are you done with this? Everybody got it? Okay. All right. So what's next? Number 10? Oh, another one. Another one with a difference. So I don't know if you need me to do another one or not, do you? I can put that data in, or if you believe it. So basically, they're asking for what this time? Assume that the test claim is paired data from a population with a mean UD equals 0. Oh, we want to compute test statistic. All right, so that's different. Remember, we now have to know if accept or reject. It depends on the critical value of which side that's hitting. So right now, they want to find out. Okay, so let's just do it. Okay, who wants to read
You
it?
want to start back at variable 1 and 2?
Do I have differences in here too? Yes. Okay, they're gone. Okay. I'm entering a lot of data today. Okay, what is it?
What was?
Well, that's what I'm asking. I'm on number 10. So 168. Now, it's the same thing. We go here, stats. All right, and we're talking about mu, aren't we? Mu, right? And paired. And sample 1. Variance 1. And variable 2. Variable 2. We want the differences. What was the confidence interval?
The confidence interval was, it doesn't, assume that you want to test the variance and.
That's okay. I mean, if it's, we don't need, well, I just wanted to set this. I didn't know if they had one. Okay. So, our p-value is, this was number 10. Okay. So, I don't want my p-value. I want my test statistic. What the hell's wrong with me? What is a test statistic? Oh, looks like it's B. Is it C or B? Let's see. Oh, it's C, right? 3.1506. Okay. The next one is number 11. Are we done with this? Are we okay? Here it says the T statistic, which is the actual stats. That's the test statistic. That's the test T statistic.
Well, it says that it's a paired set.
Oh, it's UD anyway. Yeah. So, and then does it have a? It doesn't. Differences. You have to mark difference for this one. And let's go here. All right, and then it wants the t-test. Yeah, there, 1.292 is letter C. Now you can figure it out if you want. Maybe you have it on your phone or something. You can have it so where it's, I don't know, formula in there. Well, you could download a program onto your phone, like scientific calculator.
Most iPhones come with that.
Huh?
Most iPhones come with that.
What?
Most iPhones come.
Oh, yeah. Oh, I didn't know that. I don't use iPhones. Let's see. I like Android. Okay. Next problem. Okay, now, all right, it says construct a 99% confidence interval for the difference between mean drying paint and mean drying time. So, isn't that the same? Okay, did they, are we on 12 or where are we at? 12? I don't think we did 12, did we?
No, we're on.
Okay. Huh?
Yeah.
Yeah. Well, that was, so, okay, we're going to construct the indicated confidence interval for the difference between two populations normally distributed. And it's also assumed that the standard deviations are equal. All right. So that the standard error of the difference, the mean is obtained pooling the variance, right? If they're small and variances are together, when you do this, you're going to have to pool your variances. Paint manufacturer wanted to compare the drying times, right, between independent sample of 11 cans of type A and 9 cans of type B. Those are your sample sizes, right? And type B, and they were all both painted on same kind of surfaces. So let's see if we can look at the dry times again. Okay, so in this case, well, we know it's normally distributed, right? Or it can be processed that way, or we can do a t-test. So it wants it. What does it want? It doesn't say. Well, let's try this. So it's a 2 sample. So let's say we go here, stats, and if we go to T, is it paired or not, or is it just 2 sample? Let's say 2 sample. Do we have summary? No, we don't have that. Let's see, stats. Let's do that. 1 sample. Well, it's a 2 sample, isn't it? What am I doing? Isn't it? It's 2 sample. No, I don't want that either. Because I don't. No, I know what the mean is, don't I? Yeah. I know what the mean is. Let's see, 2 sample. With summary. Do I know the mean? I know the standard deviations are equal, right? And I know that the sample size, I have that too. Let me try this. So that was proportional. Is this proportional? It's not proportional, is it? Are these means? Yeah, it's X bar and S. And you see we're constructing it around mu1 and mu2. Oh, okay, we got everything we need. I don't know why we keep missing it. Let's see. Okay, so it's 2 sample with summary. So I have this information. What is the mean?
The first one is 71.5.
Okay, the first one is 71.5.
Yes.
Okay, and the sample deviation
3.4.
and the sample size
11.
11. So you remember that this idea of pooled variances? There's a big old equation to do it, or you can select this. Does it have a confidence interval? Okay, so we have a confidence interval of minus 1.5 to, okay, do you see A? All right. The key here was pooled because the variance of each one was the same, equal. Or if they're both really small, but not quite equal. All right, that was easy enough. Next one. Okay. So this is the same thing, isn't it? Number 13? Do you see where you have the sample, the S? Now, is it pooled or not? It says, do not assume that the population standard deviations are equal. What does that mean? That means don't use pooled. You got it? So if I go to stats, right, and I go here to 2 sample with summary, let's do it again. What's that? And what are we looking for? We're looking for a confidence interval, aren't we? Do we have that? 5 point what? Don't really have that, do I? 17.74. Oh, I know. Let's see, the sample sizes are really low, aren't they? They're only 11 and, is it 9 or what the hell? That says, 5.0 and then 17.74. Anybody see it? Is there what's closest? It's like 5.6 if you were to rank this up. 5.6. And the other one would be bigger than 17 though. It looks like B, but I'm not confident. We don't have that. What is that? What did I select? Did I select Z? Oh yeah. Okay, so that one is, what, 75.7? And the standard deviation, okay, and the sample size, and the other one we got what? Okay, now let's try that. How did that come out? Yeah. Now, the reason I went back and did it, because it said here that it's normally distributed. T is a lot like the normal, so we were really close, wasn't we? Anyway, 5.78 to 17, that's letter B. Okay. Now, yeah.
Why is this one C and the other one is G?
Well, I think the reason is, let's see, this one, it says assume normally distributed populations. And what was the other one? Which one were you referring to?
Number 12.
Number 12. It's normally distributed population too. Oh, because I was using pooled. Do you remember pooled variance? I don't think you have that with pooled variance with normal distributed. Let's see. Okay, so if I go here, okay, and I go to stats, and I go T, and I go two paired, and I go with summary, right? You see this box? You don't have it in normal distribution. So if they tell you that sigma 1 equals sigma 2 or they're close about, then you're going to have to hit that and then do your, okay? Okay. All right, now, this is some material that you have not seen, I don't think, unless you've already done all of Chapter 9. What are the tests that we're testing for? We're testing the mean, right? That's a parameter, mu. Yes? What's another one? Sigma, right? And the other one is like a proportion. Is that correct? But what I'm trying to get at is that if you noticed on the two sample on Chapter 9, we haven't talked about variance of two samples. We haven't talked about comparing sigma 1 to sigma 2. You understand what I'm saying? So we have something called an F statistic. It's called an F statistic. And this is what we call analysis of variance. It's called a NOVA. But because we have more than one variable and we're looking at the analysis of their variance. So we have something called the F test. Okay, the F test. And that's going to be equal to, we're going to be trying S1 over S2. I believe they're squared. This is called the F test. You remember how we have a test statistic? This is a test statistic. What is the distribution of deviations? They have, what kind of distribution? They have a chi-square distribution. So the F test now, what is the hypothesis test? Well, remember we were talking about the two things being, that sigma 1, the population sigma is equal to sigma 2, right? And the alternative is that sigma 1 does not equal to sigma 2. This would be a two-tail, correct? And this is a test statistic that falls in that thing. So We have to learn how to read the F table, I think. Let's read the problem. Are we on number 14? Is that right? Anybody?
Yes.
Okay. When performing a hypothesis test for the ratio of two populations, the critical F value, notice that we have two critical values. We have F and another one called FR. So F is like, we're going to have two critical values. By the way, a chi is skewed. It either looks like this or it could look like this, but it's definitely not normal, but it's skewed. Okay, so what I'm saying is that we have a Z critical value here different than this one because they're not symmetric, right? So when we have a normal curve, you can see that whatever I have here with a two-tailed test, the same amount of alpha, right? Alpha divided by 2, right? But this is not the same. We have to be careful. I mean, these critical values, right? This critical value, let's say, minus 1.95. You already know this is 1.95. This is your Z values. But here's a little more difficult, I would say. And we first have to look at the F table. Do any of you have an F table? I can't find mine. But I can look it up. Oops. Okay, so let's look it up. Oh, using the F table. Oh. Let me show you how to read this. Okay, maybe this. Oh no, that's a video. Let's take a look here. Images. And all right, let's see. Maybe this one. They're selling a book. Is that it? Oh, great. All right. Let's see. I don't need this at all, do I? Okay. Let's try this one. Okay. Give me. Oh, it's a. Oh, great. Was that a video? I don't get it. I thought I hit here. Nope. Okay. Come on, I just need a simple table. I'm tired of looking at that guy. Okay, got it. What? The problem has been solved. Great. I don't want to see this. What the heck? Okay, now notice that, that this is D1 and this is D2, which, remember, I have two deviations, right? And they're going to have degrees of freedom. Okay? So when I take a look now, the one with the highest number, degree of freedom, is going to be called your numerator. The numerator is the top dude on a fraction. And this guy is going to be the smallest degree of freedom, okay? And where they, I don't want to see this. What is this? What does? Let's see. Okay, I don't know that you can see the numbers, but let's take a look at this problem and see if we can help on this thing. It says, we're number 14, okay? It says, okay, find the critical values. So we're going to put alpha in there. And then we're going to have, okay, now notice that on these tables, I don't see it on this one. Okay, right here. You see on the very top, left-hand corner. That's how much area is in the tail. All right, but this is a two-tail, so we probably should be looking for 0.025. And I don't even know if it's in here. All right, now I can make it bigger even. Now there's just a little twist that you gotta know. What am I at? Let's see, at 150, 200. Even an old man can see that, yeah. All right, now let's take a look at what they did give us in the problem. What they did give us was number 14. They tell us that you see that N1 is a sample size of 9? And that N2, that's supposed to, do you see where it looks like -7? Do you have one of these? Do I have one of these? You know, I have it on canvas, you know. But I have, I had it. Anybody else? This has 2 exam Bs. Just ignore one of them. Yeah. Now, remember that the numerator is going to be the biggest degree of freedom. Yeah. So that would be 8. Do you agree? And I'm at 0.025 table, I think. So let's try it. So you go 8, and now we go to the other one is what? Yeah, I mean 10. The first one is the biggest one. That's the horizontal. The vertical is the lower one, smaller one. Okay, now, am I here? Yeah. It doesn't say 0.025, does it?
Wait, I think it was higher, wasn't it?
Oh, up here?
Yeah, there it is.
Oh, yeah. Okay, but the other one's 11, right?
For 14.
So the degree of freedom is 10, yes? Oh, there is no 10, is there?
So, in 1 is 9.
Oh, it's not. It's 9, so it's 8. Okay, so we're okay. So now I want 8, and I want 6. Yeah, so I've got 6, yes? And then I want 8. Aha! Okay, so I want 6, and then I want 8. Okay, so voila. Now, that should be your critical value on the right side. Okay? Somebody say okay.
Yeah.
On the right side. So when I have this guy skewed like